In this video, we are going to solve this radical equation. The square root of 3x minus 5 plus the square root of x minus 1 is equal to 2. This problem is considered hard because, number one, there are two radical expressions here, and number two, this is the type of radical equation that has extra root. So let's do this together. First, let's recall that there are two things that we would like to accomplish when we are solving a radical equation. Number one, we want to isolate the terms with radical in one side of the equation. But our problem here is there are two terms with radicals. So that means we are going to apply this number one condition 2 times. And number two, we would like to eliminate the radicals by raising the equation to a power. And we are going to apply this also 2 times because there are two radicals in this equation. So let's start by eliminating one of the radicals. And let's do that by isolating first the square root of 3x minus 5 at the left side of the equation. That means all the other terms should be at the right side. Then, to eliminate this square root, we square both sides of the equation, and this is what we have. So the left side is raised to the second, and the entire terms at the right side is also raised to the second. Then this square root and this exponent 2 will cancel each other out. So our left side is now 3x minus 5, but the right side would still contain radical. Because when we square this binomial, the result would be the square of the first term is 2 squared or 4, then twice the product of the first and the second terms, so 2 times 2 times square root of x minus 1 is 4 times the square root of x minus 1, we copy the minus sign. Then we square the second term. That would be easier because we will be able to eliminate the square root and the exponent 2. So we have x minus 1. Then let's gather all those like terms, and this is what we have. We have this 3x, this plus x here becomes minus x at the left. We copy the minus 5. Then this plus 4 here becomes minus 4 at the left side of the equation. And this minus 1 becomes plus 1. At the right side, we have negative 4 times the square root of x minus 1. Then combine like terms to get 3x minus x equals 2x. Minus 5 minus 4 is minus 9 plus 1, that's minus 8. Then copy the right side. Then we can divide each of the terms of this equation by 2 to simplify the equation to x minus 4 equals negative 2 times the square root of x minus 1. We now have here a simpler equation but still containing radical. So we are now going to apply again the same procedure. We are going to raise both sides of the equation to exponent 2 so that we can eliminate this radical at the right side. So we have here a square of a binomial which is expanded as x squared minus 8x plus 16. To square a binomial, we square the first term, copy the sign, then get twice the product of x and 4, which is 8x, then square 4 to get 16. At the right side, you square each of these factors. So the square of negative 2 is positive 4. The square of the square root of x minus 1 is x minus 1 because we'll cancel out the square root and this exponent 2. Then we distribute 4 to x minus 1 to get 4x minus 4. Then again, we gather all like terms in one side of the equation because we have a quadratic equation here. This 4x at the right becomes minus 4x here at the left. This minus 4 becomes plus 4. All the rest are just copied. And then simplify. Copy x squared minus 8x minus 4x is minus 12x. 16 plus 4 is 20. Then we now solve this quadratic equation. Notice that there is no longer radicals. And we know how to solve quadratic equation. In this case, we are going to use factoring. So we need to find what are the factors of x squared. We know it's x times x. Now, what are the factors of 20 such that when added will result to negative 12? Those factors are negative 10 and negative 2. When multiplied, the result is positive 20. When added, the result is negative 12. We now have two factors, x minus 10 and x minus 2. The product of these two factors is 0, so each one of them can be equated to 0. And adding 10 to both sides of the equation, we get x equals 10 here. And at the other side, we add 2 to get x equals 2. Now, we need to check for extra roots. So we have to go back to the original equation and check whether x equals 10 or x equals 2 or both of them will make this original equation true. So let's take first x equals 10. Substitute 10 for x. So this x becomes 10, this x becomes 10. Then 3 times 10 is 30, minus 5 is 25, so we have square root of 25. Then 10 minus 1 is 9, so you have square root of 9 here. And the square root of 25 is 5, the square root of 9 is 3, 5 plus 3 is 8, which is not equal to 2. This is wrong. So therefore, x equals 10 is our extra root. That is not our answer. So let's check x equals 2. Again, substitute 2 for x. This x becomes 2, this x becomes 2. 3 times 2 is 6, minus 5 is 1, so you have the square root of 1. And 2 minus 1 is also 1, so you have square root of 1 here also. And the square root of 1 is 1, the square root of 1 is 1. And 1 plus 1 is equal to 2. And this is correct. So our correct answer is x equals 2. And this problem is now solved. We'll see you in the next video. Bye for now.